This lecture is on calorimetry. When it comes to dealing with the quantitative portion of energy, the law of conservation of energy provides a relationship between system and surroundings in support of this law. 0 equals Q system plus Q surroundings. Therefore, Q system equals negative Q surroundings. In a constant pressure calorimetric experiment, the pressure is constant, and one uses a styrofoam cup as the insulator. Why? It absorbs or releases the energy in the reaction based on the change in temperature in the mixture. The figure shown to the right is a typical coffee cup calorimeter where two styrofoam cups are nested one on top of another and covered with a cork lid or equivalent. There is a place for the stirrer to mix the contents and another spot for monitoring the temperature change for the mixture. In an exothermic reaction, heat is lost by the reaction and gained by the water in the solution. In an endothermic reaction, heat is gained by the reaction and lost by the water in the solution. Key equations are Q solution equals specific heat of solution times gram solution times delta T equals minus Q reaction. For enthalpy change per mole, it equals Q reaction divided by N. Applications to coffee cup calorimeter experiments include 1. Determine the specific heat of a metal, and 2. Determine the enthalpy of a chemical reaction. Sample problem 1 is a 10-gram sheet of gold at a temperature of 18 C is placed flat on a 20-gram sheet of iron at 55.6 C. What is the final temperature of the metals? Assume no heat is lost on the surroundings. Specific heat of gold is 0.129 J per GC, and the specific heat of iron is 0.444 J per GC. The solution to this problem is to use the definition of the law of conservation of energy, which for this problem is Q gold equals negative Q iron. After plugging in all the values and grouping all like terms, TF, or final temperature, is 51 degrees C. Sample problem 2 is a chemistry student dissolves 4.51 grams of sodium hydroxide in 100 ml of water at 19.5 C in a calorimeter cup. As the sodium hydroxide dissolves, the temperature of the surrounding water increases to 31.7 C. Determine the heat of solution of the sodium hydroxide in J per G. Q calorimeter is after plugging in the mass, specific heat, and delta T of water is 5099.6 J. By assumption, Q NaOH equals negative Q calorimeter, and thus delta H equals Q NaOH divided by mass of NaOH, which equals, after plugging in the values, negative 1.13 times 10 to the 3 J per G. It is expressed to 3 SF. In a constant volume calorimetric experiment, the volume is constant and surrounds around the sample that is to be burned by ignition in a combustion reaction. One needs to know the heat capacity of the calorimeter in order to determine the enthalpy of reaction. Heat of reaction is Q reaction equals negative C cal times delta T. Enthalpy of reaction is delta H reaction equals negative Q reaction divided by N. The figure shown to the right is a typical bomb calorimeter where the sample in a bomb cell is surrounded by a fixed amount of water. The sample is ignited, and as a result, the temperature will increase until the sample has been completely burned. It is covered with a lid for this experiment. Sample problem 3 is a 0.500 G sample of naphthalene is burned in a bomb calorimeter containing 650 grams of water at an initial temperature of 20 C. After the reaction, the final temperature of the water is 26.4 C. The heat capacity of the calorimeter is 420 J per C. Using these data, calculate the heat of combustion of naphthalene kJ per mole. In correlation to the law of conservation of energy, negative Q of C10H8 equals the sum of Q of water and Q of the calorimeter. Negative Q of C10H8 equals 20.093 kJ, and therefore Q of C10H8 equals negative 20.093 kJ. The moles of C10H8 equals 3.90 times 10 to the minus 3 moles. The enthalpy of combustion is equal to negative 5,200 kJ per mole. Here are a couple of review problems for you to work on. 1. A 1 gram sample of the rocket fuel hydrogen is burned in a bomb calorimeter. The temperature rises from 24.62 C to 28.16 C. The heat capacity of the calorimeter, including the water, is 5860 J per C. Calculate the molar heat of combustion of hydrogen in kJ per mole. 2. Assume you mix 100 ml of 0.200 m CSOH with 50 ml of 0.400 m HCl in a coffee cup calorimeter. The following reaction occurs. CSOH plus HCl forms CSCl plus H2O. The temperature of both solutions before mixing was 22.50 C, and it rises to 24.28 C after the acid-base reaction. What is the enthalpy of the reaction per mole of CSOH? Assume the densities of the solutions are 1 G per ml, and the heat capacity of the solutions are 4.184 J per GC. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.